Hello everyone, I am back with a video. I know it's been over a year since I've had a video for you guys, but I know I've had some things going on in my life that require my attention, so I just haven't had the time to set aside to making a video. However, going forward, I'm going to make a few changes so that I can hopefully get some more videos out to you. What I'm going to do is maybe sprinkle in some smaller videos like this one that I'm going to have for you today. Some videos that don't have so much setup. So again, this one today, I'm not going to have the desk cam running, and I'm also not going to be setting up a whole circuit for you. And then also less editing. So you'll probably see a few more mistakes as far as my speech goes, because I'm not going to cut out my speech and then re-record myself, because that just takes a lot of time to run through the videos, editing, and cropping, and putting all that stuff together in the post editing stuff. So all right, enough of that. The video I have for you today is going to be a mouse mover. So it's an April Fool's joke. I ordered some Arduino Pro Micros to do some projects that require controlling the keyboard and mouse. I got them and realized I didn't have my soldering iron. So I don't have any pins to hook them up to a breadboard. So I thought, what can I do? April Fool's is coming up, and I can create a project that requires no circuits. You just plug this thing in and go. So without further ado, here we go. We're going to be creating a project that is just simply writing some code to an Arduino Pro Micro that allows you to move the mouse erratically so that you can annoy the crap out of someone on April Fool's Day. Now, before I start off, I just want to say there are only certain boards that can handle controlling the keyboard or the mouse. And the one I specifically have is the Arduino Pro Micro. What you want to look for is boards that have the ATmega that ends in a 32U4 chip. I will provide you with a list, of course, but just so you know, it's specifically that chip, and I believe the other one is SAMD. I'm not sure. I haven't used those chips, so I don't know off the top of my head. But with that said, let's get started. So I have a new sketch here. First thing we want to do is we're going to want to include the libraries we're going to be using, and for this we're going to be using the mouse library, and that's it. So we'll do an include with the brackets mouse.h, and this is a library that's included in the Arduino library or API or whatever you want to call it, so you don't have to download anything or install anything. It's all ready to go. Next, I'm going to want to know how far should I move my mouse. So we'll create a constant int. We'll call it max distance, and we'll start off with 10. So what this is going to do is we're going to move the mouse in the X and the Y position. You can do either or both. And the distance is going to be a max of 10 from where the mouse is now. So I'll show you a little bit more later, but basically that means that it can go to the left, to the right 10, or up or down 10. So what I mean by that is it can go from -10 to +10. And so this is just the max distance from its starting point, how far you want to go from where it is now. Next, we want to set up our code, and we're going to do that here. So I always have my comments here, set up objects. We want to use the serial port, and I'll explain that in a second. We want to set up we're going to be using a random number because we want, like I said, I'm going to have a range from -10 to +10. In order to set that up, we're going to do a random seed, analog read 0. Now this is a common way to set up the random seed on an Arduino. The seed is basically, without going into too much detail, it's a way to provide a set of random numbers. I guess that's really a bad explanation. Just to put it simply, if you use the same seed, you're going to get the same random numbers generated each time you generate a random number. So you want that seed to be different each time so it generates more of a realistic random number. And this is a pretty common way to do it, is just use the analog read, because if there's nothing hooked up to the pin, such as the A0 pin, that's just going to read whatever value is floating in there, and that can be anything from 0 to 1024. Okay, and then we're going to set up our mouse, which is the same as a serial port, because it's just like any other port with serial.begin. We do mouse.begin. Now here is the tricky part. When you do this, do not forget this part. you're going to be uploading code to an Arduino that when you plug it in, it's going to start making your mouse go crazy. So if you want to be able to upload your code, you don't want your mouse going crazy. So you want to give yourself some amount of time in the beginning. And let's do that. So give some time in the beginning to stop the code. Okay. So I want to be checking the serial monitor for, let's say, I'll just say 30 seconds. I want to check the serial monitor for 30 seconds to see if anybody inputs a character. If I do, then I'm just going to stop the code, and then it's just going to require a restart. So the way I usually do this is since you want to be able to monitor, you can't use a delay. So going back to my multitasking video, we have to get the start time, and we'll just say that that's right now. And then while right now minus the start time that we recorded, because the start time is never going to change, is less than, and it's 30 seconds. So we'll do this. And like I usually do, I don't like to have these in what we call magic numbers. So I'll create a variable called initial delay milliseconds. Let's do it this way. I already have the time recorded in my copy paste, so I don't want to mess that up. So, okay. Const unsigned long initial delay milliseconds equals 30,000. So now I don't have that magic number in there. Now it's pretty obvious what I'm waiting for. So while the time has not exceeded 30,000 milliseconds, we want to, let's say, stop on user input. Now, obviously, this is a custom function, and I'm going to need to define this myself. So what I'll do is, and I'll explain later why I'm doing this, rather than just having the code inside the while loop. Okay, it doesn't return anything, so we use a void. And now, in order to stop on the user input, what we need to do is we need to check for a user input. And that is as simple as just saying if serial.available. And what this does is it returns a number based on the number of characters that are available. So all we care about is it not 0? If there's nothing nothing available, it's just going to be a 0, which is equal to false, and it's not going to do anything. But if we have anything in there, what we want to do is just wait forever. So that's always a while true. And rather than just wait forever, we want to notify so that we know that it actually stopped. So we'll do a serial.println chaos suspended, restart required. All right, so now let's just make sure this is going to work. Stop on user input. If serial's available, then we wait. Oh, this is just going to print repeatedly forever. So let's just put a super long delay in here. I don't know, we'll just use, and I'm not going to use a variable for this just because it's pretty obvious we're waiting for 60,000 milliseconds. We're right inside the delay function. Here it's not quite that obvious what we're waiting for and what the 30,000 is. So there I would require personally using a variable over a magic number. Okay, so now we just have to write the code. And what we want to do is we want to move the mouse. And unfortunately, you can't get any information based on where that mouse is. So we can't use any of that to our advantage. But all we're going to do is we're going to call mouse.move. And this accepts 3 parameters. The first one is going to be the X position. The second one is the Y position. And the third one is the scroll, which we're not going to mess with the scroll, but feel free to do that on your own. So for X, that's how far we want to move in the X position. It accepts negative numbers or positive numbers. If you put a negative 10, it's going to move to the left 10 because It may be a little confusing, but the way monitors work is up here in the top left, this is 0, 0. And then down here in the bottom right is going to be your max X and your max Y. So X goes from left to right, and Y goes from top to bottom. So negative Y will move the mouse up, positive will move it down, negative X will move it left, positive will move it right. Not that any of that matters because you're just going to be doing a random number, but that's just how I work. All right, so for X, we want to do a random number. So that's going to be random. I know, pretty easy. And then what you want to do is the minimum and the maximum. Now the key here is the minimum is inclusive and the maximum is exclusive. So if you do a max distance, which is what we're going to do, we'll do a -1 times max distance. So that's going to be up to -10, or I guess down to -10. And then we're going to do up to +10. But because it is exclusive, it's only going to actually go to 9. So what we want to do is add 1 to it. So now it will effectively go from -10 to +10, and any number in between that results in an integer. And then we can really just copy the same thing, but it's small enough that I will just do this. Oops. Okay, there we go. And then we don't want it to happen ridiculously fast, so we'll put a delay in here. We'll put 10 milliseconds. And just because this is something I might want to change, I will make this, we'll call it mouse move delay. And tack on an MS so we know it's milliseconds. Const unsigned long. Oh, I copied the number again, but it's a small enough number, I don't really care. So I'll do this. And we said it would be 10 milliseconds. So there we go. All right, that should be it. Now it's going to move the mouse, wait 10 milliseconds, and then keep moving the mouse. Now, this max distance is going to be specific to your resolution. And since we can't get any information from the computer, you kind of need to know a little bit of information about the computer you're going to be plugging this into. If you know it's going to be a computer that has a very high resolution, 2K, 4K, something like that, then 10 is probably not going to be high enough. This one, I believe, is a 1K monitor. I'm not positive. I think it's around 1,000 pixels, or 1,200 in the X direction. So 10 would be almost 1%. It's going to move about 1% of the monitor. Okay, tools, make sure our board is selected. Make sure the COM port is selected. Now the tricky thing is it's called an Arduino Pro Micro, but it uses the same bootloader as the Leonardo. So when you plug it in, you want to use the Leonardo bootloader or the board that says Leonardo. Now, nicely enough, when you plug it in, the COM port says Arduino Leonardo. So it's pretty easy to notice if you don't remember that it's supposed to be the Leonardo. So I get a little leery of running this because I don't want it to go crazy, but I will show you one thing here. All right, so I'm going to upload it. Nope, I messed up. What did I mess up on? Looks like, oh, I did not close this random. Kudos to you if you caught that. I did not, however. All right, so it's got a startup of 30 seconds. So it's just going to be sitting there for 30 seconds waiting for user input. And that makes me realize now I forgot the whole reason why I made this into a function was I wanted to be able to also call this in here. So that if you don't catch it in the first 30 seconds or whatever your initial delay time is, then you can catch it while it's still already running. Now this isn't going to be able to catch it. So now you can see my mouse is going psycho. But now imagine I didn't put this delay in here and I say, oh crap, how do I upload this? You can't upload this because you can't get to the upload button. So the nice thing about this is we've only messed around with the mouse. So we can still use the keyboard. Alt gets you to the menus. You can either hit one of these keys that are underlined here. I'm trying to show you with my mouse here. It says F, E, S, T, or H if you want to move to the different menus. So what you can do is, if this is a new computer, you can make sure you go to Tools. Oh, that's not good. Just make sure the mouse is way out of the way. Okay, so now you would go down here, you'd select your board, you'd select your port if it's not already selected, and then what you can do is you can go to the sketch, which is S. Oh, it won't let you do it from there. Okay, just hit left, and then I can go to upload, and I can upload this. Okay, so that is one way to be able to upload to your code, or to your board, even if your mouse is going crazy. Now that it's uploaded, I have that 30-second delay, and you'll see here if I type in a G, chaos suspended, restart required. So now if I restart it, I'll push the button here on the board. Oh, never mind. Pro Micros do not have a reset button. Which also reminds me, if you get the Pro Micro, make sure you get the USB version. I believe there is a non-USB version. I don't know if it's still around. It's been 10 years since I've used it. Just make sure you get a USB version that you can actually plug into USB. Otherwise, it kind of defeats the whole purpose of this project. But, so what I'll do is upload again. That way it'll reset. And then I will speed up 30 seconds.
7 days later.
I'm going to have my monitor open just so that I can hit the key and then X out. Okay, and the chaos has begun. So now you'll see that now that I have that stop on user input in my loop, I can just hit F and now it's stopped. Okay, and now you can go in and you can make any code changes that you want, and that's all set. So that is project number 1. Project number 2 is a little bit more advanced, I guess, in a sense that it's going to use the multitasking features that I talked about, because you want to be able to use, you want to be able to accept a user input, and you also want to be able to move the mouse at the same time. So you can't use delays because you want to be able to get the user input while that's going on. So for this one, let's see, what can we reuse? We can reuse this, so we'll keep that in there. This really is not necessary, so we'll get rid of that. And then what we want to do here is this one's going to actually move the mouse. It's not going to just wiggle it around and like crazy. So we don't need this. What we'll do is we'll say const int screen height. And then we'll say I don't know, we'll say 800. That's pretty safe value. You can go outside of the bounds, but it's possible that when you move the mouse, it's just going to jump to the edge of the screen. Screen width 1000 is probably a safe bet, so I'll do that. And then because, like I said, when the mouse moves, it's going to be moving and based on where it is now. So let's imagine the mouse is in the middle of the screen. You don't want it to move an entire screen width over. So you want to take those in half. But rather than, that's not going to, rather than having to know that for this, we can just say, let's call it half height equals screen height divided by 2. And we'll do the same for screen width. All right. And now this is all going to be the same. We're setting up serial monitor, setting up a random seed, beginning the mouse, giving ourselves a grace period so that we can stop this if we need to. And then in the loop, so instead of wiggling the mouse around, what we're going to do is we're going to, since this is going to be a multitasking situation, we're going to need to create our own function just to kind of clear up the code here. Oops, sorry, not void. Let's call this move mouse. Okay, so then let's create a function called move mouse. And again, it doesn't return anything, so we can just have void as the return type. Okay, and this part is going to be basically what you would have seen in my advanced, or not advanced, sorry, I'm working on that video. You would have seen in my multitasking video. I'm working on an advanced multitasking video. I've gotten a lot of questions about uh, how to do certain things, and the one that I provided was pretty basic, so I'm going to have a little bit more advanced stuff on there. Okay, so we would need a static variable to store the time since the last execution. And we'll start off with 0, so we'll say that it hasn't happened yet. And then we need another one for the execution interval. And I guess we should probably make these unsigned longs, since the result of millis is an unsigned long. Thank you for that comment on the video, by the way. All right, next step is to update the time. And time since execution equals same time since execution plus elapsed time. And I did not pass that in, but let's say unsigned long elapsed time. Okay, and then I'm going to need to modify this so that it passes in the elapsed time, but I don't have that set up yet, so I will just put a to do. Okay, so that reminds me to set that up. I could have just left that empty. When I upload, it'll just say that there's a problem. Okay, so now then we have our basic if statement. So if this should execute, and that's going to be if time since execution is greater than or equal to the execution interval. Okay, and that's this right here. So the execution interval is going to be how often we want this to execute. We'll say we want it to execute every 10,000 milliseconds. And then our code, let's see, code to execute goes here. And then, so I don't forget, we want to reset the time interval. And for this, what I'm going to do is, I didn't do this in my multitasking video, and I'll explain this more in the advanced multitasking video. I'm resetting this to 0. So what this is going to do is if it doesn't execute for a certain number of times, then it's not going to execute 10 times to make up for all the missed times that it executed. Okay, that's all I'm going to get into there. It's not really important for this video. So now what we need to do is we need to compute our mouse movement. So we can do mouse.move, and then remember it's X, Y, and then the scroll wheel, which we're not going to use a scroll wheel, so we'll just do this. And I guess just to make it a little bit cleaner, I might do this separately. So we'll do random X, random Y, and then what we'll do is we'll just store those in variables. Random X equals random half width times -1. So that's the bottom half. And then half width plus 1, because remember it's exclusive for the top end. And I forgot that again. So, all right. And then Y is going to be the same. So we'll just copy paste this for the video to make it a little bit faster. It's going to be half height though. Okay. And then I need to go back here and set up my mouse move to supply the amount of time that has elapsed. So I will just call this elapsed time. Okay. And this again goes back to the multitasking video. So you're going to need a global variable to hold the current time, or the last time that it was recorded, the last recorded time. So that's going to be there. And then at the beginning of each, we will update this. Oops. Update the times. So unsigned long elapsed. Ugh. Elapsed time equals millis minus last time. And now the first time we recorded last time was up here. So it's going to be whenever we immediately turn the Arduino on, which should be relatively close to 0. And then we'll just record the new last recorded time after we had already done that calculation. All right. And then, yeah, so now elapsed time, we're passing that into mouse move. And now we're still able to, so it's going to go into mouse move. It's only going to execute mouse move if we've exceeded or been equal to the execution interval, which is 10,000 milliseconds. So every 10 seconds, it's going to execute this move mouse. It's also going to check for a user input. So we still have the ability to stop our code in this case as well. So let's try this.
Seven days later.
Okay, and there we go. It just moved down here. In 10 seconds, it'll move again. All right. So there we go. I mean, that's pretty much all there is. You can make it a little bit more advanced. Move the mouse and then also jitter all over the place, so it's completely unusable. And you can be the hero. So if you plug this into someone's computer and they start freaking out, oh my god, what's going on? Why is my mouse going like this? You can walk in and you can start digging around, look in the back, look in the cables, and go, oh, I think I figured out what it is, and then just unplug your Arduino, and magic, you look like a hero. I'm just kidding. But seriously, if you're going to play this joke on someone, make sure it's someone who does not get upset very easily, because you don't want them damaging the mouse, smashing it against the desk when they get upset that it's not working. So I hope you enjoyed this video. And if you have any comments, suggestions, or questions, please leave them in the comments. I'm almost always answering the comments. Just look at any video that I make. You'll see a response to almost every single comment that has been made. So thank you again for your viewership, and I will see you next time. Hey everyone, thanks for watching. If you like this video and you want to see more like it, give me a thumbs up. And don't forget to subscribe.